Okay, in this video I'm going to show you how to do a regression and correlation using SPSS. Recall that what we are looking at are going to be variable that looks at the height of the waves at Waimea Bay and can it predict the number of surfers in the water at Waimea Bay. So I have a variable with height of the waves, and then my dependent variable is going to be number of surfers in the water at Waimea Bay. So the first thing I ask you to do is to do a scatter plot. So you want to go graphs. I like to go legacy dialogues, scatter, where you can simple scatter. See how that's in black like that? You want to choose that. Define. Okay, where you can mess up is messing up on your x and y. What you want to explain is your dependent variable, or y. That'll go on the y-axis, sorry. And then what we want to use to explain the changes in it is the x-axis, or the independent variable. That's going to be the height of the waves. So we're going to see if changes in the height of the waves at Waimea Bay can explain changes in the height of the number of surfers in the water at Waimea Bay. So make sure you don't get those mixed up. Push OK. Okay, so that's the first thing you want. So notice that the height of the waves is on the x-axis. That's our independent variable, and then number of surfers in the water is on our y, or our dependent variable. And I made up these data, so there you can see that nice linear relationship that we're looking for. Okay, the next thing we're going to do is do regression, analyze, regression. You're going to go linear. Okay, again, you can't mess up your dependent and independent. Dependent is y. That's going to be height of waves. I'm sorry, number of surfers in the water. And then independent is going to be height of the waves. Press OK. Okay, here's your SPSS output. What I say is just look at the p-value. And I can never forget which of one of these down here is the p-value. I can never remember. I can always forget, excuse me, if it's the top or the bottom. And the way to know is that the p-value will always match ANOVA. Okay, so there's the p-value. It's very small. It's less than 0.005. Okay, so we'd say it's a significant regression. If you wanted to use the 7 steps, there is your TR value, 12.581 in step 6. Okay, here is the slope of the regression line, 3.396. Up here, constant, minus 12 is your y-intercept. And here's your r square. I will show you how to do a correlation output, but again, you could use this if you wanted. Here's your r square, 985. Again, this is going to be your p-value, which will match that p-value. Your r squared, again, is 969, or we would round that to 97%. Okay, so we could say because we have a significant regression, our r squared is meaningful. It's 97%. So 97% of the variation in the number of surfers in the water at Waimea Bay are explained by variations in the height of the waves at Waimea Bay. Okay, so that's what r squared means. I will talk about r in a moment. Okay, so this is regression output. You could also use it for correlation. That would be your r, or 985. We would call that a strong positive. And you'd have to read the lecture and also lecture 21. So read lecture 21 and lecture 21C, and at the end of lecture 21 and 28C I show you how to interpret R. Okay, so we would stop this video right now to keep it nice and short. Again, real quickly, to create the graph, we go graphs, legacy dialogues, scatter plot, simple scatter. Make sure that you have your x and your y in the proper places. This is your dependent variable. This is your independent variable. You press OK. There's your scatter plot. And to get a regression, you go analyze, regression, linear. Again, you need to have your dependent and independent correct. And there you go. That's the output. Okay, so that's the end of the video.